3, and we are on Unit 3, Lesson 1. And we're going to start by looking at this equation, y equals x squared subtract 10x plus 16 on a graphing calculator, and also y equals x subtract 2, x subtract 8 on the graphing calculator. And so we're going to practice a bit today, but I'll show you what I'm doing. But I'm going to enter these two equations under the y equals button. All of the buttons along the top of the graphing calculator are your graphing helps, and so I'll put y1 as x squared subtract 10x plus 16, and y2, my second function, as that one. So just for recall, I had typed in second function plus 712 to get rid of all the stuff from my other classes, and then I have turned it on. And I am going to the y equals button right here so that I can enter my functions. y1 equals x squared subtract 10x and 16. Let's have a look at that for a second, see if it is in a good position on our calculator. Not too bad at all. I don't need a domain so far to the left because I can see it quite nicely. I'm going to adjust my domain that my x max is only -2, just to see it a little better. Okay, there is my graph. And we are going to compare that to y equals x subtract 2, x subtract 8. So none of these are negatives, they're all subtract. You would use that negative button at the bottom if there was a negative out the very front here. Just to be careful, because that's this little issue that keeps showing up on the graphing calculator. So to compare these two graphs and see what's the same and what's different, I'm going back to y equals. My second function will be bracket x subtract 2 bracket x subtract 8. All right. There's the first one. You can see that it's still working over here. It's done working and I don't see anything. Well, the truth of it is they're both the same equation. They look identical on the graph, and they are identical, just in a different form. So our goal for this unit is to look at quadratics in different forms, because some forms are easier than others to find different things. What can you find from the equation? The y-intercept, the x-intercept, the axis of symmetry, vertex, maximum, and minimum. So let's look at the first equation, y1 equals x squared subtract 10x plus 16. That one will tell you the y-intercept. Let's just verify that I'm not lying to you. I would like to see a little higher on that y-axis, so I'm going to adjust it to 15. Let's see. Not quite high enough yet. Let's make it 20. And I want to verify that I have the right number for my first equation. I'm suggesting that the 16 is the y-intercept. So if I want to check that, its second trace is to that calc button. And I want to know the value when x equals 0. It is 16. So there is a point 0, 16 on this graph, which comes from there. Let's find the other key pieces of information and see what the second form can tell us. I'm going to look at my maximum and minimum values. This one opens upwards, so it has a minimum. Second trace, there's minimum as option number 3. This is where I look to the left. Well, I'm very to the left, so I'm going to go down a little bit. Okay, now I am to the left of that minimum. Hit enter, put a marker up above, scroll around till I'm definitely to the right of it. Put a marker. There we go. Find the minimum between there and there. 5 and -9. So minimum 5 and -9, and this is the vertex. So I see one number that was really helpful is that vertex, but that 5 and -9, I'm not seeing it right away from either one of those two forms. Let's look and see if we can find the x-intercepts, because that's another thing they asked us for. Okay, x-intercepts, that's my zeros on this thing. So second trace 0, 0 number 1, I'm going to do the left one first. So I've got to find my cursor. There it is. So I'm going to go to the left of that there, to the left of that x-intercept, to the right of it, and hit enter. So the first x-intercept is 2. I wish I could write on that space, but I can't. Is 2, 0. Okay, let's find the other one. The other 0. And I know some of you have been using Desmos, and I'm not sure how to find these key features, but I have no doubt that it would be friendly. And to the right of it, hit enter, and the other x-intercept is 8. Interesting. Do we see the numbers 2 and 8 anywhere? Absolutely. So this form can tell us the y-intercept quite easily. This form can tell us the x-intercepts quite easily. Now, if you look, that point, just a second, I'm going to clear this. That point 5 minus 9 is the minimum point, the very lowest point. We know from previous experience that the axis of symmetry runs right down the middle. It is like a dotted line is how we've often drawn it, to cut that parabola in half. And the x value of that axis of symmetry is going to be x equals 5. Is our axis of symmetry. Still not sure where we get that number from in those two equations, but I'd like you to keep it in the back of your mind that that 5 is going to be helpful. So we're going to work a bit on our algebra and deciding what it is that we can glean from the two forms. So this first example has been written in factored form. Factored form was the one with the brackets, and it can tell us our x-intercepts. So before we write it in standard form, let's see if we can decide what the two x-intercepts are. We get the two x-intercepts when y is 0. So last unit we were setting each one of those brackets equal to 0 separately and solving to find our 2x intercepts. The first bracket, 2x subtract 1, if that is equal to 0, I'm going to add 1 to both sides and divide by 2. So I have an x-intercept of a half that was hiding a little bit in that bracket. X plus 5 equals 0 is my other x-intercept. I'm going to subtract 5 from both sides, and I have my second x-intercept. That one's easier to see. What we're asked to do today is to write this equation in standard form. That's with no brackets. And it will tell us our y-intercept. Okay. I'm just going to erase this, and we are going to do FOIL on our equation just to write it in a different form so that it'll have no brackets. So with FOIL, I do my firsts, 2x times x, 2x squared. My outsides would be 2x times 5 plus 10x. My insides, negative 1 times x is negative 1x. Negative 1 times 5 is negative 5. Collect like terms, 2x squared plus 9x, subtract 5. From that, I know my y-intercept happens when x is 0. If I put a 0 here, the first term disappears. If I put a 0 there, the second term disappears, and I'm left with negative 5. This number at the very end in standard form is always your y-intercept. Second example, we're going to write that one in standard form. We have to multiply, we do FOIL, and we have a 3 to deal with. My suggestion to you would be Leave the 3 till later. Do your FOIL first. So we're going to write it in standard form with no brackets. Here's FOIL. X times x, x squared. Outside would be x times negative 2. Inside would be 1x, and lasts would be negative 2. I'm going to even tidy that bracket before I deal with the 3. X squared, and I have negative 2x plus 1x. I have negative 1x. Careful with the negatives. Then we're going to deal with the 3. Distributive law means the 3 affects everything in the bracket. So final answer, y equals 3x squared, subtract 3x, subtract 6. So my key features would be my y-intercept comes from standard form. When x is 0, y would be negative 6. My x-intercepts come most easily from factored form from the 2 brackets. You could set each bracket equal to 0 and solve, or notice that my 2 x-intercepts will be negative 1, 0, opposite sign to what's in the bracket, and 2, 0. Going the other way, we have 2 equations in standard form, and we want to write them in factored form. So we're thinking backwards right now. I want to write it with brackets. So my thought process for factoring something is there a greatest common factor more interesting than 1? Not for the first one. Is it a difference of squares? I always think about that second because it's easy to recognize. Nope, there's 3 terms. So this one is a trinomial. And I have to think about whether it's a simple trinomial or one where I need decomposition. This one is a nice simple trinomial because there's only an invisible 1 there. Let's write y equals and 2 sets of brackets. If I'm going to factor this trinomial, I know for firsts I need x and x. For lasts, I need 2 numbers that multiply to negative 15. And then for outside, inside, I need 2 numbers that add to negative 2. My 2 numbers are going to be 5 and 3. My only choice would be 1 and 15, because I'm always brainstorming multiplication first. One of them has to be positive and one of them has to be negative. And if I want to add to negative 2, the 5, the larger, would be negative. So x subtract 5, x plus 3, is factored form, and they're both equivalent. My key features would be my y-intercept comes from that first form, standard form. When x is 0, y is negative 15. My x-intercepts come from factored form, and my 2 x-intercepts are when y is 0. The first one would be positive 5, be careful. The second one is negative 3. Last example. I have one that I want to write in factored form. I need to think, is there a greatest common factor? Yes, there is for this one. It's 2. So I'm going to do that first. 2 times what gives me each one of those terms? 6x squared, 5x, and a negative 1. So I'm not done. I'm going to look at my brackets and see if I can do anything further, because I know what I want it to look like this, so that I can see clearly what my 2 x-intercepts are, and I can't at this point. So it is not a difference of squares. There's 3 terms. It's a trinomial. Is it a simple trinomial or one where I need to do decomposition? It has an ugly 6 here. I need to do decomposition. All right, fasten your seatbelts. We can do this. We are going to decompose this thing such that I write my 5x in 2 parts. The 2 parts are going to add to 5, because I can't change the question, but also multiply to, I'm thinking about those 2 numbers, negative 6. So one of my numbers is positive, one of my numbers is negative. So my choice will be 6 and negative 1. The temptation is 2 and 3, but there's opposite signs going on here. I'm going to have to stick to 6x, negative 1x. I've decomposed the problem. Now I factored by grouping those two first. Right, y equals, don't forget to write your 2. Now I'm going to factor these guys. I see a greatest common factor of a 6 and an x. 6x times what gets me what I started with? Well, I need an x for that first term, and I need a 1 to hold the second term. Pause. Now we're going to factor the last two. I need a greatest common factor for those two, and the only common factor would be a 1. I'm going to write my common factor as negative 1 so that in the brackets I can have a positive x and a positive 1. And now I notice that my two brackets are both the same. Next line, y equals. Don't forget to write your 2. For this whole mess, I see that of the two terms, x plus 1 is a common factor. I need my leftovers in the other bracket. So x plus 1 times 6x, and also negative 1. And I have factored it. The first form tells us our y-intercept. Your y-intercept is when x equals 0, and it would be negative 2, coming from here. The x-intercepts come from the second form when y is 0, and I have one x-intercept from that bracket, which is negative 1, and I have another x-intercept from that bracket. Oh no. If you can do it in your head, number one, I'm proud of you, but be careful. I'm not sure about that one, so I'm going to set it equal to 0. I'm going to add 1 to both sides and divide both sides by 6. So my x-intercept from the second bracket is 1/6.